In the name of God and merciful compassionate, I am Behruz Ahmadi from Iran, Tehran, work in TVTU, Technical Vocational Training Organization. Here we want the total tutorial safety electrical in industry, theoretical applicant. Theoretical applicant, first we begin with what is the electricity. Simple glance to what is electricity. Electricity is production in power station and after production transmission and distributed to the customer. Example, building, residence, industry, something like that. We take a glance, a simple glance to the quantity of electricity. What is the quantity which we measure the electricity? We have quantity like volt, ampere, resistance. Over here, I glance to the electricity. What is that? Electricity is two kinds: direct current and alternating current. Abbreviation of this DC, abbreviation of the AC. This is two currents we have, two kind of production. The production of electricity, electromotive force, actually is phi, Z, NP, and 68. 68, that's production. After, we don't want to talk about this, but after here we have direct current came to the customer, the electricity. We have quantity of current and voltage. This voltage we use after the world currents in the years 80 between the two scientists. One scientist, Nikola Tesla, and Edison, inventor man. The Tesla won this war and choose alternating current for the manufacture and distributed and transmission for, because it has advantage, more advantage to this. Okay, we talk about over here right now about the AC current. AC current has sinus wave over here. We want derive the RMS and means voltage. Here is the peak. For example, 6 volt. Here is 2 volt. Here 4. Here 6. Here 6. And over here 4, 2. We say V means equal 2 plus 4 plus 6 plus 6 plus 4 plus 2 divided 1, 2, 3, 6 equal 4. 4, that means over here, we make the formula. We made formula, which means equal V peak times 0.634. Over here we prove it. V means V 6 times 0.634 almost is 4 volt. So this formula is important. In this quantity, V means equal Vp times C0634. With this formula equation, we can find V means and Vp2. Okay, talk about RMS. Before we go to the tutorial safety electrical in industrial, I prefer talk a little about have a glance to the quantity of electricity. What is the electricity? What is the voltage we talk? We talk about voltage, phase and line. Voltage, phase and line. We measure it with multimeter. That's roots mean square. We had 6, 2, 4, 6, 6, 4, 2. Over here. We powered 2 all of this and put it in the radicals. 2 or 2 plus 4, 2, 6 power 2 plus 6 power 2, 4 power 2, 2 power 2 times 2 divided to 6. Almost 112. And in denominator we have 6. If we over here divided 112 divided 6 equal 18.6. 18.6. We put this in under the radical. We take the answer is 4.3. Okay. As means voltage, we find out over here. We made equation over here too. We say V RMS root means square. Root means square too. Okay? VRMS is equal with P times 0.707. Okay, we have here 4.3, 6 times 0.707. We have 6 times 0.07042. You see, this almost equal and close. For this, we have right now other formula for RMS. I send to you. Okay, the result is the V means in AC current equal VAP times 0.634. Also, I means current equal VAP times 0.634, and also V RMS. This RMS is that quantity we know the formula with that. For example, in Iran, the phase voltage is 220. When we talk about 220 volts, it means VRMS. That's VRMS, not V means, not V peak. In America, 120, 150. VRMS in America is 115, 120. Pay attention, which voltage we take and read from multimeter is VRMS. Equal VP times 0.707. Also, RMS, IAP, sorry over here, wrong, IAP times 0.70. We have other formula for RMS, VP divided to 1.42. This equal to this formula. We have two formula for find the VRMS. VAP divided 1.42 or VAP times 0.700. Okay, that was the glance of the quantity, most important quantity in electrical. Okay, after this, for this tutorial, electrical safety in industrial and commercial, or even in building, we have to have some warning and boosters warning. Over here we have some important warning. For example, 3 factors in shock electricity are as resistance, voltage, and current. Low resistance of the body and higher of electrical potential, that's the reason for shock electrical. Even the more high voltage be higher, the danger of shock electrical will be more than that. Even the current be high, the danger proportional, the danger of shock electrical will be more. the times of touch electric car. The times of touch electric car is very important. Less time, danger is less. More time, the danger of shock electricity will be high. Some of these warning, for example, the wet scan is very important. We have to have all the time pay attention. Don't touch any electrical wire, even not live wire, hot wire. Any electrical wire with wet hand. Okay, we will talk about here which range of voltage we talk is danger. The most danger in according the United States standard NEC, dangerous voltage for touch, maximum dangerous voltage for touch in American standard is 30 volt. Dangerous current, dangerous maximum current in American standard is 5 milliamperes. In VDA and Germany standard, dangerous maximum dangerous voltage is 50 volt. In VDA, the maximum current, maximum dangerous current is 30 milliampere. As you see here, the voltage and current is too dangerous. 5 milliamperes dangerous. 3 milliamperes dangerous. In forward of this tutorial, we talk more and more about the circuit, equal circuit, protective circuit, and the reason of why the current and voltage is dangerous in protective circuit in forward of this tutorial. Okay, over here in the tutorial of electrical safety, we have pay attention in fire too. We know the fire may, when you have material which can burn it, as a textile, as clothes, as cotton, paper, carpet, everything which after fire we have ash of that. The reminder will be ash is the fire kind A. The fire kind 2 is made by oil, benzene, gas, and some things like this. And the other, this kind of fire, we call it B kind of fire. The C is fire which made by electrical elements, wire, contactors, generators, motors, and everything, electrical boards, electrical distribution boards, electrical transmission. We have to extinguish and extinguishing of this fire, we have to use different capsules. For fire A, we use water for extinguishing. For fire B, we use foam. For fire C, use also foam as CO2, hydrocarbon. And they are made in the capsules with different color. But the color is not all the countries the same. But I give you examples about these colors. For example, for water, the capsule of water is the capsule of waters over here. This is my book in Iran. Is black and white. But the capsules of water all the time is red. The capsule of the foam is cream. The capsule of powder is blue. The capsules of gas CO2, that's black. And other capsules is Holland. The Holland used for extinguishing fire B and C. That's green. In extinguishing fire, which the cause is electrical, in the field of in the electrical, the fire, we use all of these capsules except water. And for also fire kind 2, because we're talking about over here, we want to talk about electrical safety in industrial, especially in oil refinery industrial. Over there, and this installation, we have fire kind B too much. In fire B, we have to use all of this capsule. We can use all of it except the water. And fire for extinguishing fire kind A, we use the capsule of water and capsule of powder, just two this kind, not the foam, not the gas, not the hollow, just powder and water. We extinguish it, fire kind A. Okay, we have to go to over here. We have to go to the talk about earth peat. Okay, earth is other wire of distributed and electrical phase earth and protective earth. What is the reference of earth wire in electrical distributed electrical transmitter? Is earth, ground. We have to make ground or earth where? Earth peat in a ground. How? We have 2, 3 or 4 or maybe many kind electrode of the earth. For example, the rod, pipe, trap, and also iron pile of the building, and many of these we can use for earth. But according to standards, we have the kind most familiar and most used and most better kind of earth width is the kind which we use electrode, copper electrode in dimension 50-50 with wide 2 millimeter, 3 millimeter. And we use this kind of electrode, copper 50-50, 2 millimeter wide, and we put this, we take the wheel to this place. Pay attention. We dig the wheel until we find out the dew place. After we find out the dew place, we put a electrode, copper electrode, 50-50, with thickness 2 millimeter or 5 millimeter. 50-50. This is centimeter. Thickness 2 millimeter. After we put this electron in the dew place, find the dew place, we put the electron and we splash of that salt. How much? 50 centimeter. After that, we put on the salt the cow. After that, again salt 50 centimeters. After that, we put the salt cow again 5 times. Cow and 5 times salt. Alternative. Then we put the clay of that we take it first from digging of the wheel. We filter it and put the clay under the electrode and take out this wire, twisted wire, without any cut. Without any cut, we take the wire and we use this wire as a earth or protective earth. We use in this and put it in the distribution board of our installation. After that, we have to measure this resistance of this earth wire. which we made it. We have to measure it with earth resistance. Earth tester. Earth tester are too many kinds in market. You should buy an earth tester and have too many kinds, digitals, analogs, and also times ago we use electromagnetic, the magnetic kind. That's very important. We have to, after the installation, the earth wear and earth pit, the resistance must be more low, better. It's between 2 and 5. 5 ohms. This value is many suggested, recommended the value by many standards, American, Germany, IEC, International Electrical Commission, 5 ohms. Too many kinds ground we have. Too many kinds. One ground is agricultural. The row of agricultural place is 5 to 50. And the row of the ground, wet ground and swamp ground, 5 to 20. The row of the row I talk about, and will write for you the formula of row and RE. The row of the plaster ground, plaster land or plaster ground, the 10 to 150, and the ground of the sand beach is 200 to 50, and row of the place and land or ground of stone is too much. 500 to 10 kilo ohms. In this place, at the place of the which have a high row example, sand ground or stone ground, they are too hard to take 5 ohms. For this reason, we have to use doping with water in your pit earth or your well bread with some pipe or with some you have to doping with some, put some holes in water pipe to make wet your pit earth or your where earth or pit earth. To doping of and power it to take in place which have a row too much as a stone place, ground, sand ground. But in a wet ground and swamp ground is very easy because they are the row of that place is very low. Okay. We can find out what is which kind of arc, land or grand. With this formula, RE, the RE is resistance Earth, but rho is resistance of our land or ground. For example, the resistance or land of Tehran or place. Tehran is agricultural, 33 ohms. I find out it with my student 10 years ago. That's different, rho and RE. We have formula, equation with a pipe electrode. Pipe electrode is as a pit electrode of copper electrode, is that we use the pipe electrode. We just put it with hammer, we weigh the end of the pipe, we weigh and put it with a hammer and dig it to ground, to the land. This pipe, 2 meters. And after that, with this formula, rho equal RE times L. L is the length of the pipe, 2 meters, divided 0.9. You can, with this formula, after you find out your resistance of earth of the pipe kind of earth pit kind of pipe, you find out this, and that the length of is 2 meters. You can find out what is your which kind of your land is: swamp, stone, plaster, mountain. This is parameter is important for installation, because when you have to specification of your installation, where earth and safety electrical, you have to find out which kind of your land is. Okay, after these subjects I talk with you with the weak language of mine, we have to go to the forward lesson. The forward lesson, we talk about what is the protective circuit in electrical shock and hazard in our installations, our place, our factory, our industrial, our building, our commercial building. I introduce to you the circuit, equal circuit for accidental touch the wire of electrical. What happened and how we could we could make the less hazard with our installation with our circuit and with our some forming of the forming made of the circuit to prepare which the people didn't have shock electrical in their places. In here we have the first circuit, protective circuit against accidentally touch voltage. What is the R circuit? What we can to do to avoid shock electrical to that person which had accidentally touched with a hot wire of electrical. We have to talk about this quantity for you. UV. What is the UV? Touch voltage. Remember American 30 volt maximum and Germany 50 volt was the range of maximum touch voltage. The UV is touch voltage. IM is the current which pass from man bodies. This current, the maximum range 5 milliampere or 30 milliampere. We should prepare circuit, prepare things to our installation to avoid the person which had an accidental touch in electrical wire to shock electricity. What are these circuits? How we take a shock from here? Equal circuit. Here is RL1, the resistance of the wire after the transformer. RL1. What is the RL? RL, the resistance line of the customer distributed. 1 ohm. That's 1 ohm. Over here, this is Rn. What is the Rm? Resistance. Rm, resistance of man body. Over here, we have, for example, 3 kilo. Maybe it's in wet body less than that and dry body more than that. But we choose 3 kilo between wet and dry. The position of normal. Over here we have RS. Then we have R, sorry, over here we have RU, then RB, RS, then RB. RU, what is RU? Resistance. Resistance between man and ground. Because RU. Okay. What is the equation of that? That was equal circle. The equation of find out if I touch electrical wire, hot electrical wire, if I touch, be alive or dead, what is the equation of that? How can we made it dead to the life when we had an accidental touch electrical wire? Okay, we call over here IM. The current has human body equal U systems in around 220. In United is 120, 150. The denominator we put RL1, 10. Put RL, 10. RN, 3000 ohm. RU, over here we put 500 ohm. The resistance between me and ground. Then 2 ohm and 2 ohm. Pit earth and pit earth. RS, my RS, and distribution substation, pit earth, my installation, pit earth 2 and 2. Okay, plus all of this and find out the result. Any divided 3000.6. Okay, almost 62 milliampere. This is 62 milliampere. That's dangerous current. Dangerous current because we have 5 milliampere maximum and 3 milliampere. Okay, after this, we find out the current passing the body is dangerous because more than 30 milliampere. Here we have to find out with this current UB, touch voltage, UB equal IM times RM. Or here we have UAB 62 times 62 milliampere times 3000, almost 160 volt. 160 volt is very high than 50 volt maximum touch voltage. Okay, our circuit, we find out our circuit over here is not what? Is not safe. We have to save it. How? I show you. Again, we have also in this circle UF. UF. What is the UF? L8 and RL8, RL, RM, RU, RS, RB. Here is UB. Here I cure UF. What is UF? UF equal IM times RM plus RU. In here we had UF, IMAX, IM was 62 milliampere times 3000 plus RU 500 volts, almost 220 volts. Same as U system. I introduced to you, you be familiar with UF2. Okay, how we save our circuit, our installation to make safe for our person. Again, RR1, 1 ohm, RR plus RM plus RU plus RS plus RB. RB. No. Neutral line. We change here because we cannot change this. We cannot change this. We cannot change that in our circuit. That's too low. We cannot make this lower than 2. It's too hot. And also this. Just the item. The item we can change it is RU, resistance between me and ground. Which what? Which mat. Mat under my feet. Mat wood. Mat plastic. And other more important, safety shoe. Safety shoes make these 5,000 ohms or more than that. $50,000. We change 500 a normal shoe. We change our shoes or put a say a mat wood or mat plaster under my feet. We change this to 500 to higher. Behind that 500 to 50 kilo. And with 50 kilo we calculated our resistance again to see what happened. Okay, I am equal 220. 1 plus 1 plus 3,000 plus 50 kilo plus 2 plus 2. Okay, over here almost we have 12 milliampere. I think again calculated 12 milliampere. 12 milliampere is also for us which 30 milliampere is high, maximum high touch voltage. Over here we have 12 milliampere. That is for us the safe current. Okay, we calculate also UB in here. UB IM times RN. IM 12 milliampere. 3,000 is almost 36 volt. 36 volt. Or that's less than the 50 volt, the maximum touch voltage. Right here, right here, we find out, we made the circuit, the position which if I take accidentally the electricity wire will be safe. Okay, we find out also UF. We find out the UF doesn't make any difference. The UF all the time is as same as voltage system. Okay, the most reason, the best reason for this circuit are go just make done IM and UB less than 30 milliampere, less than 50 volts. Even if it less than 5 milliampere and 30 volt, that is very better. That is will be good and our requirement. Right now, we have to talk about. Okay, sorry, I corrected the result of our IM. The before equation was 4 milliampere, and UB was 12 volt. I made a mistake. That was 12, say 12 milliampere, and this I said 36 volt. Change it to 12 volt, UV, and UV 12 volt, and IM 4 milliampere. Sorry, I calculated wrong. I said to you to correct it. Okay, talk about other condition. Other condition is not accidentally. Is earth leakage. Earth leakage, when earth leakage, earth shorted to our case of our body of our equipment, we have to have another circuit over here. We have other circuit here. IF. The IM, change it to IF. Current fall. R. L1. Again R. L. Here, instead of RM, we have RK. What is the RK? The RK is resistance between the case of equipment device, example, electrical motor, refrigerator, electrical compressor, electrical tubes, everything. Resistance between case of equipment and phase or line. In normal condition, RK, normal condition must be infinity. But when it shorted with case, will be zero. Here we talk about that condition which we have the short circuit between phase and case of our electrical motors or devices. Look over here, RS and RB. Again, we will find out the spark current IF 2020 220 1 ohm 0 plus 2 plus 2. Okay. Divided 4, 5, 6. Divided 6. It's almost 36. Pay attention. We have to make a circuit which could act our fuses with this current. With this current, do our fuses act or can't? Our fuses is 10 ampere. for example, 10 ampere. We have IA, current in fuses, equal I and nominal current fuses times coefficient, the stable coefficient 3.5, some coefficient of cut of fuse 2.5, some coefficient of fuse 1.5. This depends to the fuses is rush ag or low ag. Here is low ag. Okay, 10 times 3.5 is 35 ampere. In here, we see there are fuses 10 ampere. With this condition of our circuit, after the short circuit between phase and case of body, the fuses immediately will be cut, because this is 36, 35. Immediately is cut, and this is our favorite and is our wanted. Okay, if our fuses be 20 or 30, what will happen? We cannot change anything of that. The happen is that our fuses didn't act or act too many times after 1 hour, 2, 3 hours. And between this during time, me or some person touch that devices, they across with what? Shock electrical. For this reason, in industrial, commercial industrial, and building in this industrial, we use electrical leakage circuit breaker. And in industrial, we use protective devices. For example, protective motor contactor, protective compressor contactor, protective as a fuse and for safety and for safety circuit. Over here, we have to substitute or also put fuse or substitute protective circuit breaker in industrial, in commercial and building. We should use add a fuse. You should add, in addition of fuse, earth leakage circuit breaker. We over here talk about what we'll do earth leakage circuit breaker to cut out the short circuit. Even our fuses be 50 ampere, 60 ampere, even 80 ampere. In earth leakage circuit breaker or E L C B. We have other quantity I delta N, call it I delta N. 1 ampere, 300 milliampere, 30 milliampere. In addition of IN, nominal current of this circuit. For example, 10 ampere as a fuse, the nominal as a fuse. 20 ampere, 63 ampere as a nominal. We have two quantity. One is 1 I delta N and other is IN. In this circuit breaker, here are IF 220, IFR fuses are, for example, 36 ampere. And we have ELCB 1 ampere nominal with R delta N, I delta N 1 ampere, and IN equals 63 2. But I delta N of this are ELCB, which we use it before fuses, and put the earth and phase in inter, and the input and output also take earth and neutral, and the phases which in output of the earth's ELCB, we supply it to the fuses. It's supplied to fuses. Okay, 1 ohm plus 1 ohm plus 0 RK plus 2 plus 2. Here we had a 36 ampere. 36 ampere never cut out the fuses. But here we talk about here we have I delta N 1 ampere. Immediately cut out the RELCB. This is best way for avoid of electrical shock in commercial place and resistance place or building place, house place, or commercial, even in industrial. But in industrial, we use practically circuit breaker for electrical motor and our devices which have too much IN. Here we solve the accident touch in body of the our devices. We can we avoid the electrical shock of for person with this situation. Use ELCB in addition of fuse. In industrial, we use protective circuit contactor, protective circuit PKZ, for example, in Muller company, and many company have the protect. Or here in industrial, when you use PK protective circuit, don't need you use fuses. they are fuseless. And here we solve the electrical shock to person even with accidentally touch with a safety shoe, and also in accidentally short circuit between phase and case of our devices with use of ELCB. And we want to talk about the other thing in electrical safety. Electrical safety of in our installation in industrial, how many kind of distributed circuit we use. We have IT distribution system, TT, TNS, and also TNCS. We talk about all of these situations, all of these circuits. But before that, I want to say the other advantages of protective circuit or ELCB. ELCB, we have REUB max times I delta N. For example, 50 times I delta N, 50 ohm. REUB max I delta N, 50, 30 milliampere, other kind, 166, REUB max I delta N, 50, 30 milliampere, 66. Oh. Okay, what do you see over here? What is different? What is the advantage? The advantage is that we use ELCB in your installation. You don't need have 2 ohms in RS, electric earth pit, earth wheel, earth electrode, 2 ohm to 5 ohm. With one use ELCB with rate either time 1, if you had just a pipe as an electrode and dig the ground, pipe 50 ohms is enough, because this ELCB act in the touch the person, the wire, live wire, phase wire. Even more than this, with either the end, 300 milliampere, 166, your earth electrode. That's good advantage on 100,666. That's very, very, very important for that place. We talk about it, a stone place, a stone land, mountain land, which you could very hard to take less resistance for your well, earth wear, RP 5 ohm, you use, when you use the ELCB, you have a good and safety installation. And also talk about the step voltages. The step voltage step voltage. What is the step voltage? This is your place RS or RB. If you have this short circuit, and the safety devices didn't act in the ground of here, for example, here, or in radio of 0 meter, 5, 10 meter, 20 meter, 30 meter. We have a table over here. Zero meter, 120 volt. Yeah. Step 1 meter over here. 1 meter, we have a step voltage 81. 2 meter, 51 step voltage. 5 meter, 25. 10 meter, 8. 20. 0, 30, 0. And VAS, VAE minus S1. You say for example, VAS 100, the first step, 120 minus 4 step, we had a 120 minus 80 volt. The first is 1 meter was 81 volt. 2 meter 51 volt. Equal 41. The VS1 is 41. S2, what is the S2? 81 minus 51 is 30. 81 minus 51, 30. 51 minus 25. 25 minus 8. 8 minus 81 minus 51. All made is, even you part away from your earth electrode part away, more part away, your voltage, step voltage will be less. Until that place, you should measurement. Until that place, 20 meter over here, 30 meter, will be zero. After you find out the zero step voltage, you round it with the fans and something warning looks like alarms light to pay attention. The other person here maybe be dangerous. In that time, we are all equipment, our protective equipment didn't act. We have voltage around the ground pit wheel and around the electrode earth place. That was something about a step voltage. Even with far away from the electrode, the step voltage will be low. We close the earth electrode, the voltage, step voltage will be high. We have to beware. We have to formula the person beware of these plays with the fans, red fans around, installed around the electrode earth. Okay, we are right now talking about the distribution, the distribute kind. We talk about distribution system. Distribution system. After the step down, post transformer or here the line voltage. We want made in additional line voltage also phase voltage. Phase voltage we make the earth pit, earth electrode or B. We have too many different kind of distribution system as TNS, TNC, IT, TT, also TNCS. We talk about our different distribution system. First, we have to talk about their letters. What is mean of these letters? If first letter was T, it means we have RB, Earth Electrode Post Substation. We have RB. If the first letter was I, it means we don't have RB in our system. Or we have but we don't use it. Okay. We don't have. The second letter, if was N, it means we use RB. If was T, it means we don't use RB, we use RRRS, R Earth's private electrode. We made a pit for ourselves, separate of RB. As the third letter, if was C, that means we made neutron and protect Earth together from the center star transformer. As a pen, if the third letter was C, if the third letter was S, it means we have separator P, E, and neutron. That means PE and neutron. We separate far away from. It's not common PE and C because what is separate? That was the means of letter. I talk about that. Tell you. Right now we explain all of the kind. First T and C. T and C. This is trans of our substation, step down, and this is our RB electrode, earth electrode, L1, L2, L3, kind T and C. System T and C distribution. Okay, T and C. The T we have RB, and we use RB. C, common PE and neutron. Okay. L1, L2, L3. Over here, the distributed board for one phase and three phase. One phase, and this is fan. And is fan. Here we can and also this means part of your installation pile iron or construct or body of your devices. You can use, you can join all of these to your pen connection to. And this kind of system TNC is kind of for installation, common installation, protective earth and neutron. Sometimes we use this for private installation, and this is the kind of which is underground system. It's not the air system. Okay, the other distributed system. The other distributed system is TNS. TNS TNS system. T, we have RB, and we use RB. S, spray, and PE. L1, L2, L3, L1, L2, L3. Over here, single phase, 3 phase with neutral. Here with protective earth, U2 on multiple earth as pipe, pile constructor, pile iron constructor, body of your equipment. You can use the other things to add your protective earth. For that reason, we have much less resistance of RB to act on protective devices as a fuses, as talked about before. Okay, that's the advantage of TNS.